Welcome to Chapter 8, Part B. This we're going to be doing an experiment for Boyle's Law. So as you can see here, it says this cannot be done at home. I want you to describe the procedure from the Zoom session here, but we're not doing them on Zoom. I realized last semester that didn't work. So what I want you to do here is take notes and write down what we're doing here. So first of all, remember what Boyle's Law means. So at this point, you should have already studied that in your slides. If you have not, stop watching the video, go study it in your slides first. We're going to be combining and looking at pressure and volume, or volume and pressure. And what we have here are kilopascals for our pressure. Okay, so first of all, over here I have this equipment that you would be working on in the lab, and I have a gas pressure sensor, and I have a syringe. It's marked at 10 milliliter, and you'll notice that all of these have 0.8, and that's because the space here between, when I screw this in, the space between these is going to be 0.8 milliliters. Okay, and this is just filled with air. And I have a helper here with me because it's really not possible to do this lab and videotape it at the same time because I've got to hold the camera. So I've got a little friend here, and he is helping me to record things. So the first thing that you should record, see right here it says, atmospheric pressure today, and we're doing this in kPAs, kilopascals, and go ahead and write down 102.75. Can you do that, James?
Right here?
Yeah, 102.75. Good. And kilopascals, kPAs, just like that. Good. All right, now what we're going to do next, here. All right, James, can you, while I'm holding this, can you screw the syringe onto here without changing what's inside? So hold it here.
Okay.
No, hold it here with your hand, this hand. There you go. And can you screw it in here? Thank you. Perfect, that's good. All right, let me see. Is that about as tight as it'll go without hurting it?
Probably.
Okay. Does it feel pretty snug? Let me see. Yep, okay, good. All right, now I'm gonna turn this over so that I can see it. And what I'm gonna do, so when we start this, it has 10.8 milliliters of air in it. Okay, I'm gonna compress it to 5.8, and then we're going to look and see what our pressure is, okay? Now, right now, it's a little higher, the pressure, because now we're in a closed system. Okay, but it's not real different. And this is actually pretty difficult to do, especially one-handed. So oh, wow, it's harder than you think to compress it to 5, all the way to 5 and hold it. Okay, so I've compressed it to 5, and so at 5.8 milliliters, it's 190.6. Let's go 190.6. All right. Yep, 0.6, James.
Right here?
Yeah, good. All right, and now what I'm going to do is I'm going to release it until it's at the 7. So at 7.8 milliliters, we are at 139.2, we'll say. Let's go with 139 even. Yep, good. All right. And I'm rounding this because there's a lot of change. All right, now I bring this out to 9, so 9.8 milliliters. Okay, and the pressure for that is 111.5. Yeah.
7.
All right, and now I have to try to pull on the pressure. So now we're going to see pressures because now I've pulled the syringe out, so I'm increasing the volume, and so our pressure is going down. So now I'm at 11, so 11.8 milliliters is 95.0. And now here comes the part that's hard to do one-handed. All right, okay, now I've pulled this out to 13 and I'm holding it steady. And the pressure is 81.4. Okay. Oh, and now I pull it out to 15. 15.8 milliliters is 71.3. All right, I have to set this down for a minute, sorry, to change my hold on here. All right. So that one was 13.8, James?
That was 15.8.
That was it? Okay, 15.8. So now what I'm doing is it's really, really hard to do this. I wish you guys could do this in the lab. So now we're at 17.8 and the pressure is 63.1. All right, and now one more, and this is, let's see if I can do this one-handed. All right, 19, so 19.8, and our pressure is 57.1 kilopascals. All right, you know what, let's do one more. Write 20, sorry guys, write 20.8 there, James.
Why not 21.8?
Because I can't go that far. 20.8, and at 20.8, we are at 55.1. Okay? All right, that's it. Thank you, sweetheart. Okay, so now let's come over here and remember that last, well, first of all, let's go ahead and take a look here. These are the values you need to have for the milliliters. Okay? And then these are the corresponding values that you need to write down for the pressure. 190.6, 139.0, 111.5, 95.0, 81.4, 71.3, 63.1, 57.1, and 55.1. Okay? All right. Now, the next thing that I want you guys to do, and now you should remember this from lab 3 and 4, you need to plot your data using either Excel or Google Sheets. And you need to decide, is the relationship linear? Okay, and it's not going to be. I'm giving this away. Now, first of all, let's talk a little bit about this. These values are your x-axis, your horizontal axis. And these values are going to be your y-axis, or your y-axis, your vertical axis, okay? So x and y. All right, now you need to attach a trend line. And to kind of go over that again, just as a review from the previous labs, is that trend line, that means you have to plot a scatter plot and then add a trend line. It is not a connect the dots line graph. Okay, it's not, if it looks like a dot to dot, then it's probably not right. Okay, it is not going to be linear. It is going to have a curve to it. And that means that you need to make sure that you determine your trend line based on a power and not a linear equation. So when you go in to attach trend line, you're going to need to tell whatever program that you're using that, that you need to plot the trend line as a power, not a line. Okay, now you need to determine a trend line and place the graph and equation here. So what I want you to do right here is write down your trend line, okay, equation, and add your graph somewhere to what you're doing. All right, now what I'm going to do is I'm going to come over here and we're going to talk a little bit about it. You're going to use the equation for your trend line to calculate pressure at the following. So based on your trend line, calculate the pressure at 5 mils, 10 mils, and 15 mils. Now, your trend line for this, because it's a power and not a line, before we saw y is equal to mx plus b, but we're not going to see that now. What we're going to see now is going to be something along the lines of y equals, and it might look like this, ax to the negative 1. Okay, and it's going to be in a form something like this, where x is volume and y is pressure, Okay, and A is a variable. You're going to get a number that's attached to that. Okay, another way of writing this, y is equal to a x minus 1, that variable will come from your trend line, would be y is equal to a over x. And again, a is a number of some kind. It's not really slope, but you could think of it as slope. It's a constant. Okay, good. So then you're going to answer this question, and what I want you to do here is use the data and graph to describe Boyle's law in depth. Again, by now you should have seen the slides that describe what Boyle's law is. I want you to link the definition for Boyle's law with what we see in this graph. Okay? Have fun. Contact me if you have any questions.